Hi everyone, welcome to AWS Lambda tutorial. I am Arockiadoss. In this video, we will learn about AWS Lambda, its use cases, key features, Lambda function structure, and how to create and test a Lambda function from AWS console using Python language. And finally, delete the resources we created to avoid unnecessary costs. Now, let's go into the details. AWS Lambda overview. AWS Lambda is a serverless compute service that runs code without provisioning or managing servers. The code is organized into Lambda functions and it contains one or more Lambda functions. Next, function as a service. That is, it acts as an event handler and microservice, executing tasks in response to triggers like HTTP requests. AWS Lambda is similar to Azure Function App and Google Cloud Functions. Next, automatic scaling. It means that the Lambda service runs the function only when needed and scales automatically. It can scale up rapidly and scale down to zero when not in demand. Next, pay as you go pricing model. By this model, we can save costs by paying only for the compute time consumed, and there is no charge when the code is not run. And Lambda function code can be written in the below languages such as Python, Node.js, Java, Go, and so on. Next, let's see some of the use cases of AWS Lambda. Now, let's learn about serverless architecture and how AWS Lambda fits into it. Serverless architecture is an approach to software design that allows developers to build and run services without having to manage the underlying infrastructure. The application still runs on servers, but all the server management, such as provisioning, scaling, and maintaining servers to run the applications, databases, and storage systems are done by AWS. One of the most important use cases of Lambda is that we can build serverless application. AWS Lambda can act as a compute service, that is to process the request, DynamoDB as database, and API gateway as HTTP gateway service. As you can see in the below image, the web app calls or invokes the HTTP API and the API gateway routes the request to Lambda function and the Lambda function interacts with DynamoDB for the CRUD actions and DynamoDB returns the data to Lambda, and in turn, Lambda returns the response to API gateway, and finally, the API gateway returns the response to the client application. Next use case is event-driven architecture. Let's learn about event-driven architecture and how AWS Lambda fits into it. It's an architecture pattern that uses events to decouple an application's components. For building modern applications with microservices, event driven architecture is an effective way to create loosely coupled communication between microservices. An event is a change in state or an update, like a file upload in an S3 bucket, and so on. It has three key components: event producers, event ingestion, and event consumers. Let's see a sample event architecture. Whenever a file is uploaded in S3 bucket, the new object created event, that is S3 object created put API, is triggered. As you can see in the below image, once the file data.csv is uploaded to S3 bucket, The Lambda trigger or an S3 event notification invokes the Lambda function, and the Lambda function processes the data and stores in the relational database service, which could be PostgreSQL or MySQL and so on. Now, let's learn the key features of AWS Lambda. So, one of the most important key feature is the environment variables. The Lambda environment variables is like configuration parameters for an application. We can use it to adjust the function's behavior without updating the code. An environment variable is a pair of strings that is stored in a function version specific configuration. For example, here the environment variable retry count with value 3 can be used to continue the process for a maximum of 3 times in case the process to retrieve data from DB failed without hard coding the value in the program. Next, versions. The versions feature manages the deployment of Lambda functions with the different versions so that, for example, a new function with version number 2 could be used for beta testing without affecting users of the production version 1. Next, container images. Lambda supports two types of deployment packages. One is container image and another one is .zip file archives. By this feature, we can deploy a Docker image using the Lambda function. Next, function URLs. A function URL is a dedicated HTTP or HTTPS endpoint for the Lambda function. We can access the function URL through the public internet. Next, concurrency and scaling. Concurrency is the number of incoming requests that the AWS Lambda function handles at the same time. For each concurrent request, Lambda provisions a separate instance of the execution environment. As the Lambda functions receive more requests, Lambda automatically handles scaling the number of execution environments until the account's concurrency limit is reached. The default Lambda concurrency limit is 1000 across all functions in an AWS region. Next is the layers. The tutorial will be incomplete without the discussion of the Lambda layers. So, a Lambda layer is a zip file archive that contains supplementary code or data. Layers usually contain library dependencies, a custom runtime, or configuration files. In the below image, we can see two patterns. One is Lambda function without layer and the other with layer. Here, the difference between the two is that the Lambda function without layer, the library or custom runtime has to be included or packaged with each Lambda function. On the other hand, Lambda function with layer, the Python request library is created as layer, and each Lambda function references the Python request library layer. Hence, no need to package with each Lambda function. Next, Lambda function structure. Let's learn the structure of a Lambda function. The sample Lambda function Python program shows the important method and objects in different colors. Now, let's learn about them one by one. First, the Lambda handler method. The Lambda handler method is the entry point for the Lambda function. The execution starts from this method. For example, Lambda handler method in Python, the handler method in Node.js work as the entry point. Next, the Lambda event object. The Lambda function handler takes two arguments. One is event object and another one is the context object. An event in Lambda is a JSON formatted document that contains the data for the function to process. Next, the Lambda context object. The context object contains information about the function invocation and the execution environment. Lambda passes the context object to the function automatically. The context object can be used to output information about function's invocation for monitoring purposes. Next, logging and monitoring in Lambda. AWS Lambda automatically monitors Lambda functions and sends logs to Amazon CloudWatch logs. A log group is created with the same name as the Lambda function in the CloudWatch logs. We can use built-in logging module or third-party logging library that writes to stdout or stderr. For example, the statements console.log or console.error in Node.js or print in Python will send the log data to CloudWatch logs. Next, prerequisites. For this tutorial, you need to have an AWS account and you can create a free tier account and you can find account creation link in the description. Next, create and test Lambda function. So we will do a demo on this in this Lambda function creation. So from AWS console, we'll create a Lambda function using Python language. Next, I will explain briefly about the Python code and the JSON data used for this tutorial. Next, we will test the Lambda function from AWS console. Now, let's go into the AWS console, create a Lambda function and do the hands-on exercise. I have signed into the AWS account with my user ID. So now let's create a Lambda function in the AWS console. So here, once you log in, you will see this screen and in the search bar, type Lambda service. So once you type Lambda, this will come. You can click this and it will take you to the Lambda screen. Here, click this create function and here I will create a Lambda function from scratch. So you can use an already existing blueprint or a container image. So here I will be going for code and I will build it from scratch. So here input the function name. Then the runtime. So here I will go for Python 3.13 and this architecture is okay. So here permissions. So this Lambda, when we run the Lambda, it will create a log group and write the log to the CloudWatch log. So we need Lambda to access the CloudWatch log. So here I will select on this create new role with the basic Lambda permissions. So we will see the contents later in the once the Lambda function is created. So you can also have an existing role to attach it. But here for this tutorial, I will go with a new role. Next, if we click this additional configurations, so as of now, these are not necessary. Here, one thing to be noted is this enable VPC. So as you know, the Lambda function runs as in the AWS network. So if you want to put your Lambda function in your VPC, you can create in the Lambda inside your virtual private network. So as we are given the basic information, now let's click the create function. So this may take a very few seconds. So let's wait until the function gets created. Yes, now we can see that the Lambda function has been created. So here I will explain some of the important features in this Lambda function. So here you can see this trigger. So once you click this add a trigger, as we said that event driven. So you can select S3 bucket or anything. So as for event driven, so whenever an file is uploaded to S3 bucket, we can run this Lambda function and do the process activities. So here we can input whatever the full details, then it will trigger once the file upload is done in the S3 bucket or whatever events. So here you can see what all for which event you want run the trigger the Lambda function. So for this tutorial, I will not go so detailed into it. So just for your information, I am explaining it. Next, here as I discussed the layers. So for example, you want add a Python request library. So you could have created a package. Then here you can click this add a layer if you have already added in the Lambda layers. Next here, one of the another important thing is this add destination. So in case your Lambda function fails or because on success you want to write something or on failure you want to write something, so you can redirect the messages to an SNS topic or SQS, or you can even call a Lambda function. Now let's run a sample Lambda code that I showed in the tutorial before. So let me get my Python code. So I have already a Python program. I will copy and paste it here. So now I have created a sample Python program. So this one I will explain here. So as I said, there are two objects, event and context. So this event contains the data. Now I will pass a JSON data file which contains these items. So ID, name, email, and that will be passed to this event object. So here I will read those items and print those items as with these strings. Then I will print using the context object the log group name. Then I pass these values to the data, then return this data in a JSON format. Now once we have created the Lambda function with a new code, we need to deploy to reflect the changes. So click this deploy button. So we can see that successfully updated the function IT skill master Lambda. So now our code has been deployed. Now let's test our Lambda function. So for this we need to create a test event. So click this create test event. So just give some name, test event 1. So here you need to provide the data. For this I have a sample JSON data. So as I said before, it has just three items: ID, name, and email. So let's create a test event and save it now. So our test event has been now created. Now let's test this function and see whether it is running successfully or not. Now click this test button and we need to select the test event that we created. So I created test event 1. Select this, and here we can see this output status succeeded test event name. So here we will see the output. So here you can see customer ID, customer name, customer email, and the CloudWatch log group being created and the details. So we can see that the JSON data that we have passed here has been read from the event object and it's printed successfully here. Now, as I said, once we run the Lambda function, it will create a log group in the CloudWatch logs. Now, let's move to CloudWatch log and check the details. For this, if you click this monitor button, here you can see the view CloudWatch logs. So here click this and it will take you to the CloudWatch log group. So as I said, the CloudWatch log group will be created the same name as the Lambda. So this, you can see this. This is the Lambda name and a log group has been created. And here you can see our execution of the log stream here. So just click this and you will see the log data. So whatever we have used, the print statements, all are printed here. So now we can see that the log details have been exported or printed in the CloudWatch log group. Now let's go back to the Lambda function and we need to check for the role, execution role that is created. So for this, now click this configuration and click this permissions, and here you can see this execution role. Now click this and it will take you to the IAM role that has been created when we created the Lambda function. So this is the role that has been created. Now let's click this role and see the contents. So you can see here, so access level limited right. So this it allows Lambda to create a log group, create a log stream and put log events. So for to create a Lambda function and run it successfully, we need this basic IAM role. So as we have created a Lambda function and tested successfully, now as I explained to you earlier, we will see some of the important things. So the environment variables. So here we can add an environment variable, as I said here, say click that one and add, okay. Then the value. So these we can, so we need to put underscore, hyphen is not allowed. So now we have added a environment variable and we can use this variable in our program. So if you want, say for example, as I said, to run your Lambda function in case of failure, retry attempts, you can update this value at any time instead of hard coding in the program. Next, as I said, function URL. So if you want to call your function from the web, you can use a URL and call it from there. As I said before, VPC, if you want to put your Lambda function inside the VPC, we can add the VPC details. So if I want to put, it's a default VPC, so I can select this and put my Lambda function inside the VPC. So these are some of the important items that you need to know regarding the Lambda function. So we have learned about in detail how to create a Lambda function and test it from the console. Now let's go and clean up the resources that we have created to avoid unnecessary costs. First, let us delete the CloudWatch log group that is created automatically by the Lambda function. Now go to CloudWatch logs. So here you can see the log group. Select this log group and click actions, delete log groups. So this will ask, are you sure you want to delete the following log groups? Yes, click delete. The following log group has been deleted. Okay. Now, as we have come to the role, now go to if you cannot see this role, you can go to always Lambda function, click the configuration and click the permissions and navigate to the IAM role service screen. So here already it's open. So I select this IAM role. So this is the role that is being created, that has been created. So I select this role, IT Skill Master Lambda role, blah blah. Click delete, and you need to provide the role name. Copy and paste it here, and click delete. So now the role is deleted. So just for confirmation, we can go to the Lambda function, refresh it. So click this and it says the specified entity does not exist. So it means that the role has been deleted. Now in the same way, click this monitor tab and you can see view CloudWatch logs. Click this button and it will take you to the log group. So we can see that log group does not exist. So we have already deleted the log group and the IAM role that was created for the Lambda function. Now let's go to the Lambda function itself and delete the Lambda function. So here select the Lambda function and click actions and click delete. So here type delete. So the function has been deleted successfully, closed. Now if we go to Lambda, so we can see that 0 Lambda functions. So we know that now the Lambda function and the role that has been created for the Lambda and the CloudWatch log group all have been deleted. That's we have cleaned up the resources successfully for this tutorial. We have created for this tutorial so that we will not incur unnecessary costs. So that's all in this AWS Lambda tutorial. Thank you very much for your patience, and let's learn about API Gateway in the next tutorial. Finally, a simple request, please like, subscribe and share to your friends if you found this video useful. Once again, thank you very much.